In this lesson, we'll be looking at matter and its properties. Everything you see on this slide is made of matter, from the ice cube and water to the candle wax and even the air around us. Chemists use properties of matter to identify and describe substances and to tell when a substance has been chemically changed into another substance. By the end of this lesson, you should be able to describe substances using their physical and chemical properties and to distinguish between physical and chemical changes. So, properties of matter. I'm sure you are very familiar with the standard definition for matter. Matter is anything that has mass and takes up space. Now we're going to refine that just a little bit and say that a substance is a very specific kind of matter that has a uniform and unchanging composition. That means you can write a formula for it. So there are two types of substances. The first one, gold, would be an example. So this is an example of an element. An element is a substance that only has one kind of atom. So if you have a formula, you know it's a substance, and if you see one capital letter in its formula, that means it's an element. And then the glass of water is an example of a compound. A compound is a substance that has two or more types of atoms in fixed proportions, which means fixed ratio. So for example, water is always 2 hydrogens to 1 oxygen. If you change that ratio to 2 hydrogens to 2 oxygens, then you have hydrogen peroxide, which is that stuff that fizzes when you put it on a cut. So there's a really big difference between the physical properties and the chemical properties, actually, of the two substances. And that's because they're different substances. So substances are identified by their physical and chemical properties. So just like when you go and you get a physical, the doctor is going to poke and prod you and make all kinds of measurements, but they're not going to change you in any specific permanent fashion. Whereas chemical properties, the only way you can find out what a chemical property is, like say, for example, the gunpowder that's inside this little bomb thing that's drawn on the slide, the only way you can find out if it's actually gunpowder is by setting it off. And then once you've set it off, it's no longer gunpowder. Now it's going to be smoke and sulfur compounds and carbon dioxide and carbon monoxide, a mixture of a whole bunch of different things. So physical properties can be observed and measured, like with a doctor, without permanently changing the material. So for example, color, shape, hardness, its odor, its texture, state of matter, whether it's solid, liquid, or a gas, its temperature, all of those things can be measured and it doesn't change the substance into something else. Chemical properties can only be observed or measured by permanently changing the material. So for example, if you want to find out if something is flammable, you have to try to set it on fire. The reactivity with oxygen, when I was in graduate school, we shared lab space with another research group, and all of their compounds that they were working with were highly reactive with oxygen. So they had to do their research inside of glove boxes. I'm sure you've seen them in like science fiction movies where they have the black gloves sticking out of a plastic box. And every now and then they'd go to take stuff out of the glove box, and when they would open the airlock chamber on it, there would be flames come shooting out because some of their substances that they were working with had gotten spilled on the equipment in there, and it reacted with the oxygen and turned into something else. So a physical property is a substance's odor. And it turns out that odor depends upon molecular shape. So this is a picture from a book called Molecules by Atkins. And what it is it's the kind of like the shadow that the molecule would have. So if you have 6 carbon atoms and you bond them all together, making sort of a flat pancake like this very first structure, it has a sweet aromatic kind of smell. If you take 2 of them and you fuse them together so they make this flat double hexagon kind of shape, now it smells like mothballs. If you take 4 of them and you fuse them all together, it's still flat. Now it's musky. The fact that the intensity of the aroma is dropping is due to the fact that as you get more and more stuff, its ability to get up into the gas phase where you can smell it is decreasing. So that's why, thankfully, musky smells are, you have to be really close. They don't have a whole lot of volatility. If you take one of those flat pancakes and then add a CH3 group to each one, so it's kind of like spokes of a wheel coming off on the end here, now it smells like Vicks Vapor Rub. I think my favorite one is if you have a hydrocarbon chain, so it's just this floppy noodle-like thing. That's the fatty smell, like if you go into McDonald's or something like that, it's going to, you know what a fatty smell is. But if you put a kink in it, so it has a little branch going off to one end and another branch going off the other way, now it smells like flowers. That's my favorite example of how odor depends on the shape. So there's two different types of properties, physical properties. We have extensive properties. These are the ones that depend upon the extent or the amount of matter that you have. So the mass of an object, the more stuff you have, the more mass you're going to have. Volume, length are other examples. Intensive properties are ones that do not depend upon the amount of matter that's present. Some of them are ratios of, for example, density is a ratio of grams to milliliters. So that ratio is always going to be the same. It doesn't matter how much you're going to have. And then under normal conditions, melting point and freezing point and boiling point are all going to be independent of how much you have. This changes once you start talking about like nanoscopic size things, and that's because the surface energetics start affecting how easily it can melt, or how it affects the way things can change their state of matter. So physical changes, we've been talking about properties, now we're going to talk about changes. So a physical change changes the appearance of the substance without changing the substance's formula. So for example, if you start out with an ice cube that is water in its solid state and you let it melt, it looks really, really different. You went from a cube to a puddle, but it's still water. It still has the same formula. The chemical changes, on the other hand, result in the formation of a new substance. So the formula changes. So there are 5 indicators of chemical change, and we're going to be coming back to these over and over and over again, which is why it's often a separate box all by itself. And it had a little ta-da sound. So if you mix things together and you get bubbles forming, that's an example of an indicator of chemical change. If you've ever mixed baking soda and vinegar, you've seen this particular indicator in action. If you have a color or an odor change, not the color and the odor are physical properties, but if they change, that tells you that you had a chemical change. Just think about it. If you get something from some fast food place, you decide to save it for later, and you forget about it, you come back later, and now it looks kind of green, and it's slimy, and it doesn't smell so good, you know you don't want to eat that because it's no longer all of the substances that you put in there initially. It's got a lot of other extra stuff in it now. We have energy given off. Whenever you have something burning or giving off light, it is an example of a chemical change. A temperature change, and by this I mean you mix stuff together and it changes temperature all by itself. For example, if you take vinegar and a fair amount of the baking soda and you mix them together, you should be able to feel the temperature drop. And that's because it's having to absorb a lot of the energy from the surroundings in order to form those CO2 bubbles. So the temperature change does not mean the temperature change that you get when you put like a pot of water on the stove and you're heating it up. That's where you're just making a phase change and you're adding heat to it. It has to be making these changes by itself. And then a precipitate or a solid being formed. I don't have any really good real-life examples of this, um, but we're going to be doing a lab, Unit 5 or something like that, where we're going to be mixing a whole bunch of things, and like half of them are going to form solids, and you can tell that they're solids because you can't see through the container anymore. So that'll be something to look forward to. All right, so now we're just going to look and try to figure out if we have a chemical or a physical change going on. Maybe pause the video and see if you can figure out what the answers are before I go over them. So the first one, when heated, a substance goes from a liquid to a gas. So that's just a phase change. So that would be physical. It's still the same substance. When heated, the color of a substance changes from blue to white. So that was one of the indicators. That's definitely chemical. When heated, a substance burns. You probably overheated it. That would be because it's burning, it's going to be chemical. When hit with a hammer, a substance explodes. So this one, you see, yeah, chemical. I was trying to think if it was exploding like shrapnel flying around. I couldn't remember. Or if it's an explosion as in a really, really fast chemical reaction. Apparently this one I meant for it to be the chemical reaction. So next one, when hit with a hammer, it flattens. That just changed its appearance. That's physical. When hit with a hammer, it breaks into smaller pieces. Still the same stuff, just changed the appearance. So that's physical. When water is added to a blue liquid, it changes to a lighter blue. That one could be either. It could be either chemical or physical. It could be a color change, or it could be you just, like, say you had some blue Gatorade and you added some more water to it because it was just a little bit too strong the way it was, and you diluted the original Gatorade. So number 8, when a clear liquid is added to a blue liquid, a white solid is formed. The fact that not only do we have a color change, but we also have a solid being formed means it's very chemical. All right, so when water is heated, small bubbles form on the bottom of the container. The fact that it is on the bottom of the container tells us that it's just from the heat that is being delivered to the container, and so it's starting to do a phase change where it's hotter than the surroundings. So that would just be physical. When water is added to concrete mix, the water begins to steam. So heat has to be being given off to cause the water to change to a gas. So that means that we have energy being released, temperature is increasing all by itself, so that's chemical. When water is added to dry sand, bubbles are observed coming up from the sand. So you kind of have to have gone to the lakeside and observe this yourself. If you have dry sand, there's gaps in between the sand grains, and when you add water to it, it displaces the air that's in the gaps. And so that one's just physical. And then the last one, when water is added to a metallic solid, the metal melts and smoke is given off. All right, so we have heat being released because the metal is melting. Smoke being given off tells us that we got something doing something and we're forming a new substance. So that's very definitely chemical. All right, so the worksheet that goes with this is the title of the worksheet is Chemistry in Wonderland, the White Knight Song. So there's 3 parts to it. In the first part, it just says what's a physical change, what's a chemical change, so you're just going to fill in those definitions from your notes. Second part, I'm going to give you some things like making a pretzel and peanut mixture. You have to decide whether the thing that is being described is a physical or a chemical change. You're just going to write P or C down in the blanks. That's very similar to that understanding check that we just did. The last part is where we have a little bit more explanation needed. So the White Knight Song is a poem by Lewis Carroll. So it's a very old poem. Some of the terms are a little weird. And you have to interpret the underlying phrases in terms of whether they are describing a physical property, PP, a physical change, PC, and then chemical change and chemical property, those are kind of hard to distinguish between the two of them. If you just want to put down chemical, that would be fine. All right, so just to give you an example, so the very first line, I tell thee everything I can, there's little to relate. I saw an aged man, and so that's underlined. So we need to identify which of these four characteristics up here go with I saw an aged man. All right, so you could say, well, I looked at him. I didn't change him into anything else. I saw that he was an old guy. So that's just going to be a physical property. So you would write down PP in the blank, and then your explanation, which is actually the key part to this. If you just write down the labels and you don't give me any justification, you're going to get it wrong. So why looking at him didn't change it? I'm not going to try writing that out. I've had people argue with me that, well, I know aging is a chemical process and that by the time you're done looking at him, he's no longer exactly identical to the man he was before. So that could be a chemical change. This is where the label and the explanation have to match up. Most of them, there aren't really any one particular right answer. But the label and the explanation have to match. So let's do another one. All right, so I saw an aged man sitting on a gate. Who are you, aged man? I said, and how is it you live? And his answer trickled through my head like water through a sieve. And so the line trickled through my head like water through a sieve is underlined. So we got to decide what's that talking about. All right, so water trickling. It's not changing anything else, so it's definitely going to be a physical something. You can say water has a certain surface tension, which is why it trickles as compared to just dumping straight out. So you could say, well, that's physical property. Water has a high surface tension. Or you could say it's a physical change because the water is changing its shape. It's going from being held in the sieve to being droplets as it trickles out. There are a few terms that are unfamiliar, and I'm just going to leave them up here. So sieve means a spaghetti strainer or a colander. Waistcoat is a vest. A rill is a small stream. Cinders are the glowing coals in a fire. So whenever you see red coals in a fire, those are cinders. Mutton is sheep meat. Haddock is a type of fish. I had a student one time argue with me that it couldn't possibly be a fish because they had never heard of it. Heather is a thorny bush. And then the last one, I'm not going to try to say it, is just hair oil. All right, so that is it for this lesson. So let's go through the wrap up. So remember, matter is anything that has mass and takes up space or has volume. A substance is a specific kind of matter that has a uniform composition. That means that you can write a formula for it. There are two different types of substances. We have elements, which have one type of atom, and compounds, which have two or more atoms in a fixed ratio. Physical properties describe a substance without changing it. Chemical properties, the only way you can observe them is by changing it into something else, changing it into a new substance or substances. Physical changes change the appearance but not the composition, so the formula stays the same. And then chemical changes produce a new substance. The formula changes. And just remember those 5 indicators of chemical change. Like I said, we're going to be coming back to those over and over again. Next time, we're going to be talking about, let me see, mixtures. Yeah, this lesson was on substances. Next lesson is on mixtures of substances. So thanks for listening.